Hello everyone, welcome to today's class. This is Teacher Simon taking you through Cambridge International AS and A-Level Mathematics Paper 5-3 for May, June 2024. This is part 1 for questions 1 to 3. Question 1. The numbers on the faces of a fair six-sided dice are 1, 2, 2, 3, 3, 3. The random variable x is the total score when the dice is rolled twice. Part A, draw up the probability distribution table for x. Now, before we draw the probability distribution table for x, we need to first draw what we call the possibility diagram, and then we get these scores. Then from there we can know what we are supposed to put in the probability distribution table. So this one, the dice is rolled twice. It's the same as maybe rolling two dice at the same time. So I can put the scores of 1 here, 1, 2, 2, then 3, 3, 3. The other one here, 1, 2, 2, then 3, 3, 3, like that. Then when we add 1 and 1, we shall get a 2, then 3, then 3, here 4, 4, 4. Here we shall get 3, 4, 4, then 5, 5, and then 5. Then here we get 3, 4, 4, 5, 5, and 5. And then here we have 4, 4, 4. Then 5, 5, 5, 5, 5, 5. Then 3 plus 3, of course, these ones are going to be 6 all through. That is going to be our possibility diagram. Let me put it in a table. Now, from here, we are supposed to write down to do the probability distribution table. So what is it like? We have our x values here, and then we have the probability of x is equal to x. Now you can see that we are having a 2, we have 3, we have 4s, we have 5s, and we have 6s. Okay, so we put this one in the table. What is the probability of obtaining a 2? It is just 1 here. And then the total number of outcomes here, we have 6, then times 6, that is 36. So if you count these ones are 6, 6, 6, 6, 6, 6. And then it will give us 36. So 2s, we are seeing 1 out of the 36. And then 3s, we can see 1, 2, 3, 4. Okay, those ones are 4. So I'll write 4 over 36. And then 4s, we have 3 here, then 4 here, those are 7, plus 3 here, those are 10. So we can write here 10 out of 36. And then 5s, these are 6, plus the 6 here, those are 12. So I'll write here 12 out of 36. And then 6s are here, they are 9. For any probability distribution, when you sum up all the probabilities, you must get 1, okay? So if we try to add, is that what we get? 1 plus 9, that is 10, plus 10, 20. Then 32, then 36 over 36, then that gives us 1, so that means we are correct. Part B, find the value of the variance. Okay, so for the variance, we need to get the EX and the EX squared. So what is EX? The mean or the expectation is equal to the sum of all values of x. Then we get x times the probabilities. So we can have up here, we have 2 multiplying with 1 over 36. Then 3 times its probability, 4 over 36. And then 4 times the 10 over 36. And then 5 times the 12 over 36. Then 6 times the 9 over 36. like that. So when we put this in the calculator all together, what do we get? 2. I'm just going to add the numerators, okay, because the denominators are the same. So 2 times 1, that is 2, then 3 times 4, that is 12, 4 times 10, that is 40, and then 5 times 12, that is 60, and then 6 times 9, 6 times 9, that is 54. 54. So we get 168. So 168 over 36. Okay, then we also get x squared, which is equal to the summation of all values of x. Then you have x squared times the probabilities. So that means I will have 2 squared times the probability. Then I'll have 3 squared times the probability. I would also have 4 squared times the 10 out of 36. Then I can have 5 squared times 12 out of 36, as well as 6 squared times 9 out of 36. So also putting this together, I'm going to just add the numerators. So I can have 4, then plus 9 times 4 is 36, and plus 16 times 10, that is 160. Then plus 25 times 12, and then plus 36 times 9. So this one gives me 824. 824 divided by 36. Now we know that variance is the difference between the squared means. So variance is going to be equal to ex squared minus the expectation here squared. So we can have 824. By the way, you can write these ones maybe when they are simplified. It's no problem, but I just want to simplify the last one. 824 out of 36, then minus 168 out of 39. But this one has to be squared. So altogether, what do we get? We have 824 out of 36, then minus, we have 168 out of 36. And you can cross the brackets with square. It gives us 10 over 9. So I'm just going to leave it as a fraction, 10 over 9. Part C, find the probability that x is even given that x is greater than 3. Now here we are having conditional probability. So we have probability of x being even given that it is greater than 3. So that means we shall have probability of x being even intersection x greater than 3. Then out of the sample space we are picking from is when x is greater than 3. Now, for x being even, if we go back to our table, the ones that are even are 2, 4, and 6. Okay? But then greater than 3 will be here 4 and 6. We shall have here probability of x is equal to 4, then plus probability of x is equal to 6. Then I'll divide by those that are greater than 3. We have x is equal to 4, we have x is equal to 5, and we also have x is equal to 6. Okay, now the probability of x is equal to 4, it is 10 over 36, then here 12 over 36, and then 9 over 36. So 10 over 36, then plus for 5 it is 9 over 36. Then I'll divide by 10 over 36 plus 9 over 36. Okay, and then the one for 5 actually is the one I'm going to write last here. It is for 12. They are 12 over 36. So adding everything up is 19 over 36. and then down 10 plus 9, that is 19, plus 12, that is 31 over 36. So using the rules of fractions, that is 19 over 36, then we somersault the one in the denominator, so times 36 over 31. Automatically this one will go, and then the answer is 19 over 31. Question 2. In a certain country, the heights of the adult population are normally distributed with mean 1.64 and standard deviation 0.25 meters. But find the probability that an adult chosen at random from this country will have a height greater than 1.93. Now, we have probability of the height, let the random variable that represents the heights of the adult population be x, so x greater than 1.93. Now we are supposed to standardize this, so we shall have probability of z. Okay, remember z is equal to x minus mu divided by the standard deviation, so it will be greater than 1.93 minus the mean, which is 1.64, over the standard deviation is given as 0.25. Okay, so this one simplified, what does it give us? We have 1.93 minus 1.64, then out of 0.25, that is 29 out of 25, which is 1.16. 1.16. Okay, so I can put this in the calculator. On the bell-shaped diagram, we are going to have this one is positive, so 1.16 is here, so greater than will be this. That means that answer is going to be less than 0.5, because half of this is 0.5, even this one is 0.5. Okay, so I can use a calculator and I get the answer straight away. So you make sure that your start is on your screen, so you press mod, then you go to 3, that's where there is statistics, and then you press SC. When you see this on the screen, SC, now start is on our screen. You press shift, then you come to 1, that is where there is start, so you press button 1. Now there is distribution, which is on option 5, so you press 5, and then from there P, like I've already said, it is for less than, but now here we are dealing with greater than, so I'll put 3 for R, which is the greater than. Then I will just put 1.16. I press equals, so that is the answer. To 3 significant figures, I will write it as 0.123. 0.123. But if you are using the table, this one you can read it. Okay, so this one here is actually going to be, since the normal distribution given is for the less than, for me to get this one, I'll get the total, then minus the less than this. Okay, so I'll say 1 minus probability of z less than 1.16. So we have 1 minus, let's check from the table what we get. The probability of z less than 1.16. So from the list of formulae, this is our normal distribution table. Now we are looking for 1.16. This is 1.1, and then the 6 is here. So you come here, and then you also come here. So this is the probability here, 0.8770. And when you look at this bell-shaped curve, it is for probability of z less than z. Then for the negatives, you say 1 minus. Okay, now let's go back. So 0.8770. Now when we subtract, do we get 0.123? 1 minus 0.877. That is 0.123. Okay, so you get the same when you use the table or the calculator. In another country, the heights of the adult population are also normally distributed. 33% of the adult population have a height less than 1.56. 25% of the adult population have the height greater than 1.86. But B, find the mean and the standard deviation of this distribution. Now, we are having probability of x less than 1.56, which is equal to 0.33, because they said 33%. Now we are given the probability, but we don't know the z value that corresponds to that. So probability of z, because I'm supposed to standardize this. Okay, remember our z is equal to x minus mu out of the standard deviation. So less than, I don't know the z value here, let me say it is z1, then it's equal to 0.33. Okay, now you need to find the z value, which is going to be the phi inverse of this 0.33. But when you look at this table that we are having for the normal distribution, we are not seeing values of probability which are less than 0.5. Let me show you. You see all of these probabilities that we are having in here. None of them is less than 0.5. You can see for yourself. The least is 0.5. You can see already here, this is 0.5. That means there is something you are going to add on here. So it has to be greater than 0.5. So the least is actually 0.5, where z is 0. You see that? So now, for us to get the probability of the other one, that is 0.3. Remember this one, the z is just a boundary. So if you cannot get for the smaller one, then you can get for the bigger one. You instead get the one for the bigger one, okay? Because z is just a boundary between the two regions. Now, we shall therefore subtract, okay? We shall subtract 0.33 from 1, and then we get the z value for what we get from there. So, but then we are going to first do two sketches. We don't know whether z is positive or negative, because it is possible that z is negative or positive. So what you do, you can put your z1 on the left, which is a negative, and then you can also put it on the right, which is a negative. Which is a positive. Remember, this is 0, and then this is 0 here. Now you can ask yourself, first of all, we are having z, which is equal to now the phi inverse of 1 minus this one, it will be 0.67, okay? Now you ask yourself, which of them, I'm just focusing on this one here, less than z1 is 0.33. So less than, I'm looking at this part here on the left of the z1, and on the left of the z1, you ask yourself which of these two can actually give us the 0.33. Okay, it cannot be the second one, because that one is going to even be greater than 0.5. You see, so meaning this is the one that I'm going to take. This one is bigger than 0.5. So meaning the z value is a negative, so I will include the negative here. Then I will go to the table and I find the z value from there. So what is the z value? So what I do, I come to this table and I look for 0.67. So 0.6s are here, 65, 655. It is actually there, 6700. So I pick this one here, 0.4, and then a 4 there. So it is 0.44. So I will have here negative 0.44. Remember, you can divide through by a negative, okay? Now, we are going to have z, we are substituting in this one here. So negative 0.44 is going to be equal to our x, which is 1.56, minus mean, which we don't know, and then the standard deviation. So cross multiplying, we shall get negative 0.44 delta, then is equal to 1.56 minus mu. In fact, I can make one the subject of the formula. Mu can be equivalent to 1.56. And then when you take this one here, it's a positive. So plus 0.44 delta. So that one is going to be my equation number 1. Then I also do the same for this other one here. So probability of x greater than 1.86 This one is equal to 0.25. Okay, they gave it to us here, 0.25. So meaning I'm going to have probability of Z greater than, let's say Z2, since I used Z1 there, it's going to be 0.25. Again, do simple sketches here to see whether Z2 is positive or negative. So I can put Z2, on the left to be a negative. I can put it on the right. Then they are saying greater than Z2 is 0.25. So greater than, we are looking at the right of that value. Now you ask yourself, which of these two surely corresponds to 0.25? Of course, it has to be this one, okay? This one will be bigger than 0.5. You see that? Why is it bigger than 0.5? Already this one here, this part is 0.5. So you are adding something here. So meaning our Z2 is going to be a positive here. So Z2 will then be the phi inverse of 0.25. But remember, we don't have probabilities which are less than 0.5. That means I will say 1 minus the 0.25, which will give me 0.75. Then I go to the table and then I look out for this 0.75. Okay, the Z value that corresponds to 0.75. So when we come to the table back here, actually for 0.75, before you even look out for the probabilities in here, always first go down here. There are these critical values in this table here. Okay, now you can see that 0.75 is there. That means the Z value is 0.674. So I will just pick that 0.674. We are having 0.674. So meaning I'm going to have 0.674, then it's equal to the X, which is 1.86, minus mu, which I don't know, then divide by the standard deviation. Then cross multiplying, we can get 0.674. Sigma then is equal to 1.86. Okay, and then where there is mu, okay, I'm going to put this one here. Okay, so minus 1.56, then minus, because of course this minus is going to affect everything here, so they will become negatives, 0.44 sigma. Then I can bring this standard deviation this side, that term with the standard deviation this side, such that they add up. So I have 0.674, then plus the 0.44. Then I can factorize out the sigma. Okay, then it's equal to 1.86 minus 1.56. That one gives us 0.3. So meaning the standard deviation is going to be 0.3 divided by, when you add these ones together, you are going to get 1.114. Yes, 1.114. So to three significant figures, what does this give us? 0.3 out of 1.114. That is 0.269 to three significant figures. 0.269, three significant figures. So that is that. Then we can now substitute for mu in any of, in fact, in this equation here that we got. So mean is therefore going to be equal to 1.56, then plus 0.44. Don't use this one which is rounded. You can use this one which is exact. So times the 0.3 out of 1.114. So then what do we get as our mean to three significant figures? We can have 1.56, then plus 0.44 into 0.3 out of 1.114. So this one gives us 1.67, and the rest of those figures, but the three significant figures, I'll write 1.68. 1.68. That is that to three significant figures. Question 3, box A contains 6 green balls and 3 yellow balls. Box B contains 4 green balls and X yellow balls. A ball is chosen at random from box A and placed in box B. A ball is then chosen at random from box B. Draw a tree diagram to represent this information, showing the probability on each of the branches. Okay. Now, I have my box A here. I'm going to use G to represent green and then Y for yellow. So 3 yellow. And then I have here box B. Now, box B has 4 yellow, 4 green, and then X yellow. Now, when we are picking from A. So let me first draw this detailed one, and then later we simplify it. Okay, I'm having here box A. We have 6 green, and then we have 3 yellow. Now, when picking anything from here, it can either be green. Now, I'll put GA, green from A, or it can be yellow. Okay, it can be yellow from A. Now, when I pick green from A, and then I put in box B, this is our box B. Our box B has 4 green. That means when you pick a ball here and you put it in it, then it is going to be, the greens are going to increase by 1. So we shall have 5 green. But the yellows in B are still X. You see that? So we shall have X yellow. Or if you pick yellow from A, the yellows, the greens in B are still 4. But you are picking a yellow and then you add it here. So that means our green, we shall put 4 green. This is still box B. Then the yellow ones are going to be the X, which is here, plus the one that has come from here. So we shall have X plus 1 yellow. Okay. Then now you are picking a ball from here. And when you are picking, you are getting either green from B or yellow from B. Green from B, yellow from B. Okay. Now, what is the probability of picking from here? This one is 6 over 9. Okay. 6 over 9. Then this one is 3 over 9. What's the probability of picking green from here? That is 5. Out of the total is going to be this X plus the 5. X plus 5. And then here we are going to have X here, then divide by X plus 5. X over X plus 5. And then down here we shall have 4, then plus X plus 1, that will be X plus 5. So the denominator is X plus 5. And then the probability of picking a green is 4 here out of that X plus 5. And then for yellow, it is going to be X over 1 over X plus 5. So that is going to be our tree diagram. Okay. But that one is so detailed. You can simplify it just like this. You just put the sticks. So here we have green from A, yellow from A. The probabilities are 6 over 9, then 3 over 9. Then now we are picking from B. These subscripts, the A, the B, putting them to represent the boxes from where we are picking. So this can be green from B, yellow from B, green from B, yellow from B. So already up here we have seen that we have 5 over X plus 5, and then the other one is X over X plus 5, X over X plus 5. Then we have 4 over X plus 5, and then lastly X plus 1 over X plus 5. So this is what they are looking for. So that is that the probability that both balls chosen are the same color is 8/15. Find the value of x. So if we are getting for the same color, probability of the same color, this one can be when you are picking green, let's say from A, and then green from B, or you are picking yellow from A and then also yellow from B. So meaning I will have what is green from A and then green from B. So we are picking here and here. That is 6/9 times 5/x plus 5. We are having 6/9 times 5/x plus 5. Okay, then we shall add, all means addition in probability. So yellow and yellow, you can see here 3/9, and then this one 3/9, and then times x plus 1/x plus 5. Then this whole thing, we shall equate it to 8/15. And then we simplify this to get the value of x. First of all, here I will reduce this by 2. I mean by 3, 2. By 3, 3. So I will have that 2 times 5, we shall get 10 over, this one is 2. I mean, we got a 3 down, so 3 into x plus 5. And then here 3 goes here once, and then here 3 times. So meaning I will have a third, so x plus 1, then divide by 3, x plus 5, which is equal to 8/15. Now the LCM here is the same, so that means I will have 10 here plus x plus 1, then out of 3 into x plus 5, which is equal to 8/15. Actually, this 3, if you multiply all through by 3, this 3 can go in here 5 times. Okay, so that means I can write 11 plus x up there, divide by x plus 5, which is equal to 8/5. Okay, because I've multiplied everywhere by the 3. Then we can now cross multiply. This one will give us 55, then plus 5x, which is equal to 8x, then plus 40. Now I can take the x this side, then bring this one this side. Okay, so what then do we get here? It has to be 55 minus the 40, then it's equal to 8x minus the 5x. So this one will give us 3x, and then this one will give us 15. So meaning if we divide all through by 3, then the x is going to be equal to 5. As simple as that. So this has been it for this first part of the paper. Thank you so much for watching. May God bless you. If you find the content very helpful to you, kindly like, share, and even subscribe. See you in the next video.